Hello. So for this example, we're going to be using the definition of the derivative to solve for a derivative at a given point. So if you remember, right, we have a couple options for the definition of the derivative, but the sort of go-to one most of the time that's easiest is doing this limit as we can do delta x or h. I'll do h in this case. H going to 0 of f of x plus h minus f of x over, right, so this is the rise over run. Normally it would be x plus h minus x, but that simplifies down to just h, right? So this is our typical sort of general definition of the derivative, where the x is the sort of point that we're given. So we have for our function up here, right, this f of x, this x squared plus, minus 3x plus 1. And then we're looking at specifically when x equals 3. So I want to know the limit as h goes to 0 of f of 3 plus h, right, because my x is 3, minus f of 3 all over h. Okay, so obviously the first step I'm going to do is to go ahead and substitute in that function, right, the definition, the f of x. So this then is the limit as h goes to 0. So 3 plus h is going to go all together, right? So I have 3 plus h squared minus 3 times 3 plus h plus 1. So that's the f of 3 plus h. Then I'm going to have minus f of 3. So I'm going to have 3 squared minus 3 times 3 plus 1 all over h. Okay, so my goal here is going to be to get sort of the h out of the bottom, right? That's usually the tricky part, is trying to make sure that the h in the bottom is something that we can sort of simplify out so that eventually we can actually take this limit, right? Because the h going to 0 in the bottom is sort of what's blocking us. So to do that, the first thing I'm going to do, or I should say the next thing I'm going to do, is expand out, right, these square bits here for the plus h, and I'm just going to sort of number crunch that bit to make it go away, really. Well, eventually make it go away, but for now to make it smaller. So if I square this out, I'm going to get 9 plus 6h plus h squared, so that's foiling. Then I'm going to, don't forget the minus here, right? I'm going to distribute the negative 3, so I'm going to get minus 9 minus 3h plus 1 minus, so 3 squared is 9, minus 9 plus 1. So that's just 1 left over, all over h. And I'm going to continue to simplify, so limit as h goes to 0 still. Remember to always write the limit, right? We have to keep that there until we actually get rid of the limit, right? Until we actually like compute it, we have to have it tag along. So my 9 and my 9 will cancel. In fact, let me write out what I'm about to do here. This 9 will cancel against that minus 9. And this is really a minus 1, so this plus 1 and that minus 1 is going to cancel. So I'm really left with, well, I'll write it in order here. So I have h squared plus 6h minus 3h, so I'm going to have plus 3h. The 9's canceled, the 1's canceled, so it's all of that over h. Which I could also write, again to be clear for what's going to happen in the next step, I can also write this by factoring out the h. So this would be h plus 3 over h. Okay. So now, right, I can cancel out the h in the top and the h in the bottom, which will get me the limit as h goes to 0 of just h plus 3. And now we can actually compute this, right? Because the h is not in the bottom anymore. So as h goes to 0, h plus 3 is just 3. So in particular, right, my goal was to compute the derivative of f of x at 3. So this is telling me then that f prime of 3, or the derivative of f at 3, is 3. Okay. So that's all there is to it. So just as a quick recap, right, we had our definition of the derivative, this f of x plus h minus f of x for whatever x we're computing. So in this case, it was 3. So I plugged in 3 as my x. That gave me the limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. I actually substituted in what f was, right? The input square minus 3 times the input plus 1 for my input of 3 plus h, and then same thing for my input of 3. And then basically just simplified down, hoping, and indeed that was the case, that my h, right, eventually canceled in the top and bottom. So then there's no longer an h in the bottom, which meant I could take my limit, which then got me my answer. Okay. So that is that. Hello. So for this example, we are going to be calculating a derivative at a given point. So we have f of x here, the square root of x plus 1, all minus 1. And we want to know specifically what the derivative is at x equals 8. So to do this, we want to use the definition of the derivative. So remember our definition, right? So take the limit as h goes to 0 of f of x plus h minus f of x all over h, where x here is the point of interest, right? So in our case, we want to know about x equals 8. So plugging that in, what we really want to compute here is the limit as h goes to 0. So we're looking at, there we go, of f of 3, sorry, not 3, 8 plus h, there we go, minus f of 8 all over h. Okay. So our first step then is to just go ahead and, apply the definition of f, see what we get. So f is, right, going to be applied to 8 plus h, so I'm going to plug that in for the x in the f of x. So I'm going to get the limit as h goes to 0 of square root of 8 plus h, that's my input, plus 1 minus 1 minus, and then I'm going to do the same thing here. So I'm going to have the square root of my input, 8 plus 1 minus 1 all over h. Okay, so I'm going to just simplify this as much as I can before I do anything else. So the limit as h goes to 0. So there's really nothing I can do with this because it's more than one term, right? So it's sort of locked in. So I'm just going to rewrite this as putting my numbers together at least. 9 plus h. Remember, I can't split the square root over a plus, so there's nothing I can do there. Then I'm going to have minus 1 minus, so this is going to be square root of 8 plus 1 I can put together. So that's the square root of 9, which is 3. And then minus a minus 1 is plus 1. All over h. So then I can put my numbers together at least there. The limit as h goes to 0. I still have square root of 9 plus h. So I'm going to have minus 1 and plus 1 are going to cancel out. So maybe I'll mark that. Minus 1 plus 1, those go away. leaving me with just minus 3 over h. Okay, so now the question is, what do I do from here? Because I can't break up the square root over addition, and there's no real nice way of factoring this thing in here. So what I'm going to do is called rationalizing the numerator. You've probably seen this as a denominator thing, rationalizing the denominator, where you multiply by the conjugate, the same thing here, but flipping the sign in order to lift the square root. So in particular, if you haven't seen this before, I'm going to do it right here just to show you. So here I have a square root of something minus a thing, and what I want to do is create basically a difference of squares. So to do that, I'm going to multiply by that same thing, square root of 9 plus h, but then I'm going to add 3. And I can't just do that for free, right? I can only multiply by 1 or add 0, so I'm going to do the same thing. I'm going to divide by that same thing. So I have 9 plus h plus 3 in the bottom. Okay. Now it's worth a comment here to remember what we're after. What we're after is getting rid of the h in the bottom, because that's what's stopping us from taking this limit, right? If I tried to plug in 0, I would get a 0 here, and then I wouldn't be able to evaluate it. Now you might say, okay, why are we doing this? Well, let's see what happens. And this is not an accident. This is what will happen when you're dealing with roots, trying to do it this way, square roots. So here I have a minus b times a plus b. That's going to make a difference of squares. So on the top, I'm going to get difference of squares. So I'm going to get this thing, square root of 9 plus h quantity squared, minus that thing squared, over, and then this I'm just going to leave sort of as is, h times that thing, square root of 9 plus h plus 3. But let's see the magic happening here. This is going to be h going to 0. Here the square and the square root will undo each other. So I'm going to get 9 plus h. Strictly speaking, I get absolute value of 9 plus h, but we can think of h as being a positive thing, or more accurately, h as being a small thing, because h is going to 0, so 9 is going to be that same, right? It's going to overpower it and stay positive. But then I get minus 3 squared, so that's minus 9 over the same bottom, h times square root of 9 plus h plus 3. And now, as mentioned, not an accident, these 9s cancel out, which means that I'm going to be left with just an h, which means I will be able to cancel it. So this is going to work out well. So in particular, this is then equal to the limit as h goes to 0. The 9s cancel, so I have h over h times square root of 9 plus h plus 3. So now I can cancel that h in the bottom. Now again, it's worth a comment or a thought here that like, okay, I canceled the h out of the bottom, but I did introduce something else to the bottom. So I still have the risk that the bottom's going to be 0 when I plug in h is 0. But when I look at that, right, h being 0 here, I'm going to get square root of 9, which is 3, plus 3. So I'm okay, right? If this were a minus 3, I'd be in trouble. But sort of by design, it couldn't have been a minus 3. It had to be a plus 3 to get rid of this negative, right? So I'll write out one more step here. That's going to be 1 over square root of 9 plus h plus 3. And now when I plug in 0, everything's going to work, so I can do that. I'm going to get 1 over square root of 9 plus 3, which is really 1 over 3 plus 3, which is 1 over 6. Okay, that is our final answer. And just to be clear, this step here, this is called rationalize the numerator. Which again, you see this numerator. Honestly, this is why I'm not an English major, people. I think it's an E. You honestly see this more often as a denominator, right? So rationalizing the denominator is something you almost certainly have heard and done in like Algebra 2, for example, probably your pre-calc class, depending on where you took it. But sort of regardless, even if you haven't seen it before, we did it right here. It's this idea that you take the square root plus or minus the thing, and you use the opposite sign. So if it was, in this case, because of the negative built into our expression here, this minus f of x, it's usually minus this thing, right? So in that case, you would use addition, but really it's whatever the opposite sign is between the two pieces, right? So here it's a minus, so I do the same expression but with a plus on the top and bottom, and that gets me a way of getting rid of the root on the top. It does introduce one to the bottom, but that turns out not to be a problem, as we saw, right? So it's a way of getting rid of that piece, okay? So that is that.